Okay, chapter 12 is basically a continuation of chapter 10 and also kind of a mixture of 11 and 10. So in 11 we learned how to balance equations. 12 we learned how to speak in amounts. Chemists use a mole. So in 12 we're going to use the balance equations and the moles. We can kind of equate it to a recipe. For example, if we have a cookie recipe, the reactants would be the ingredients like the flour, the sugar, the chocolate chips, and the product would be the actual cookies. The recipe would be like the balanced equation. It tells you the amount of ingredients you need to make the product, the cookies. So again, a balanced equation is similar to a recipe. It provides quantitative information about the amount of reactants needed to make a given amount of products. Another way to look at a balanced equation, it provides the amount of reactants to mix, like when you're doing a recipe, and also provides the amount of products to expect, or that would be like the number of cookies. Balanced equations are really important in industry. Industry is concerned with making products for your consumption, whether it be food, pharmaceutical drugs, shampoo, whatever it is. And they need to know the cheapest way to make that good so they can get the most return on their investment. So they need to follow a recipe, and that recipe is going to be the reaction. The definition of stoichiometry is a calculation of quantities reacted or formed in chemical reactions. That's a calculation of quantities reacted or formed in a chemical equation. Okay, I wanted to go ahead and look at an example, and this is in your book too. Okay, so let's look at this balanced equation. Nitrogen plus hydrogen reacts to produce ammonia. So if we look on the left side, there are 2 atoms of nitrogen. There are a total of 6 atoms of hydrogen. On the left side, or excuse me, on the right side, there are 2 atoms of nitrogen and 6 atoms of hydrogen. So we see that it is a balanced equation. If we look at the coefficients, they tell us the number of molecules that we have. So there's 1 molecule of nitrogen that reacts with 3 molecules of hydrogen to give us 2 molecules of ammonia. So notice we're looking at the coefficients. They're exactly the same here. Okay, what if I had 10 molecules of nitrogen? Now I have 10 times the amount I had a moment ago. So all I do is multiply the coefficient by 10. So 1 times 10 is 10. 3 times 10 would mean I would have 30 molecules of hydrogen that would have to react with 10 molecules of nitrogen. And if 10 molecules of nitrogen reacted with 30 molecules of hydrogen, you would get 20 molecules of ammonia. Again, I just took the 2 coefficient and I multiplied it by the 10. Okay, instead of saying multiplying it by 10, let's say I multiply it by 6.02 times 10 to the 21. So here I have a 1. So 1 times 6.02 times 10 to the 21. Here I have a 3. So I put 3 times 6.01 times 10 to the 23rd. Should be a parenthesis there. And here I have a 2 times 6.02 times 10 to the 23rd. And what is this amount called? Not a dozen, but a mole. So how many total moles do I have here? I have 1 mole. How many moles here? 3. How many moles here? 3. What do you know? These numbers are the same as the coefficient in the balanced equation. So this idea is the main idea behind a balanced equation. The coefficients equals the number of moles. So if I ever ask you with a balanced equation how many moles of the reactant, just look at the coefficient. So how many moles of hydrogen here? 3, because there's a 3 in front of the hydrogen. Okay, what about grams of nitrogen? Well, I have 1 mole of nitrogen, right, because there's nothing written there. So its molar mass is 28. Let's just go the ones place. For hydrogen, one hydrogen molecule has a molar mass of 2, and there's a 3 in front, so 2 times 3 is 6. And then the molar mass of nitrogen would be 14.01 plus 1 times 3, or 3. Let's just say 14. So that's 17. But there's 2 of them, so we have to take the 17 and multiply it by 2. And that gives us 34. So 28 and 6 is 34, and we have 34 on the right. That is the law of conservation of mass. Okay, so we see mass, and the number of atoms are conserved. And again, that's the law of conservation of mass. Okay, what about volume? Well, we'll go back up to the balanced equation, or we can look right here again. How many moles of nitrogen do we have? 1. At STP, 1 mole is 22.4 liters. We have 3 moles of hydrogen, so there's 3 times 22.4 liters. And I actually have the wrong number there. Should be a 2, because there's a 2 right here. So 2 means there should be 2 boxes here for 22.4 liters. So I made a mistake. Okay, so total liters of nitrogen is 22.4. Total liters of hydrogen is 67.2. Total liters of ammonia is 44.8. So we can see that volume is one thing that is not conserved. The amount of volume on the left is not equal to the volume on the right. Molecules up here is another thing that is not conserved in this example. Sometimes it is, but it isn't always. Formula units aren't necessarily conserved, and moles themselves are not necessarily conserved. We have 1 mole plus 3 moles is 4 on the left and 2 on the right. That ends the lesson for today. We'll continue on in class tomorrow. Email me if you have any questions or issues. Make sure you come to class with questions. Thanks.